Okay, in this video I'm going to have a look at infinite geometric series, and I'm going to have a look at the sum to infinity of geometric series. So let's take our geometric series first of all. Let's take a plus ar plus ar squared plus ar cubed plus and so on. So let's say that goes out into infinity. If we were to take the sum of the first term, so we're just going to take the first term here. The sum of our first term is just simply going to be a. The sum of our first two terms is going to be a plus ar. So if we add these two, we're going to get a plus ar. So that's the sum of our first two terms. Sum of our first three terms then is going to be a plus ar plus ar squared. And so on. We can continue this down onto, Sn, the sum of the first n terms is going to be a plus ar squared, and so on, all the way out to ar to the power of n minus 1. Now these sums are called partial sums. So these are called partial sums of our geometric series. Now what we really want here is to get the sum to infinity of a particular series. What do we get when we add up all of these numbers? So we want the limit, really. What we're looking here for is the limit of Sn. The limit of Sn as n goes out to infinity. So we want to find the limit of Sn as n goes to infinity. So that's just simply going to be the limit as n goes to infinity, of a times 1 minus r to the power of n over 1 minus r. Remember from the previous video, this was our formula for the sum of n terms. So the sum of any particular, so the sum of three terms would be S3. It would be what you get when you add up these three terms. But we want the sum to we want to find the sum to infinity. So we have to get the limit of this here, the limit of Sn here as n goes out to infinity. So if you look at this here, you can see that a is going to be a constant and 1 minus r is going to be a constant. So really this is a over 1 minus r multiplied by this bit here. So really we can take this as, using the product property of limits, we can take this really as being the limit as n goes to infinity of a over 1 minus r multiplied by the limit of 1 minus r to the power of n as n goes to infinity. So this here is this part here, if you like, this part here of our original quotient here. That's all multiplied by 1 minus r to the power of n. So we've just separated this fraction out. So this part here is this part here, and the 1 minus r to the power of n is this part here. So if we look at that, then we've got a constant here. This is going to be our constant. So the limit of a constant is just a constant. So we just end up with a over 1 minus r here, the limit of this. Now we got to multiply that by the limit of 1 minus the limit of r to the power of n. Now remember, in our particular case here, we're going to take r as being, r here is going to be less than 1 and bigger than minus 1, or indeed the modulus of r is going to be less than 1. So r here is always going to be a proper fraction. R is going to be a proper fraction in this particular case. And we know that the limit of proper fractions is going to be 0. We had that in the previous video. So the limit of this part here is just going to be 0. The limit of 1 is just going to be 1. So we're just multiplying by 1 here. So really the limit here is just going to be a over 1 minus r. In other words, this is going to be our Sn as n goes out to infinity, or S infinity rather than Sn here. This is going to be our S infinity, because n is going to go out to infinity. So the sum to infinity of our series here, as any particular series goes out to infinity, the sum of that series will be a over 1 minus r. And r here, remember, r has to be a proper fraction. The modulus of r has to be less than 1. R has to be somewhere between minus 1 and 1. So this is the formula we're going to use to work out the sum to infinity of any particular series. Okay, so for example, I mean, if you have, let's say, a half plus a quarter plus 1/8 plus 1/16 and so on out to infinity here, what do you think you would get if you added up all these fractions? This is a geometric series, remember, where a is equal to a half, and we're multiplying each term by a half as well. So or is a half, or is less than 1 or minus 1. The modulus of or is less than 1. So if you add up all of these, what do you think you would get? Well, probably instinctively you would think you would get 1. If you added up all of these, a half plus a quarter plus an eighth, the limit of this particular series here would be 1. Okay. Now, so what we're going to do here is we're going to use this formula then to work out the limits of some series. So let's take let's have a look at an example where we can use this formula. So let's take the series. Let's see. We'll take the series a half minus 1/8 plus 1 over 32. Okay, so this is a series that goes off into infinity. What do you think you would get when you added up all these numbers right out to infinity? Well, let's write down our a and our or. Okay, so remember our formula is s infinity is equal to a over 1 minus or. So we need an a and we need or. So in this particular case here, we have a is going to be equal to a half. That's our first term. And what are we multiplying each term by to get the next term? Well, our signs are changing here, so it's going to be minus something. We start with plus, so we have to multiply it by a minus to get a minus. Then we have to multiply this by a minus to get a plus. We have to multiply this by a minus to get the next one, and so on. So it's going to be minus something or other. So what are we multiplying our 2 by here? It's 4, isn't it? Our 4 eighths give us 32. So it's going to be a quarter. We're going to be multiplying by a quarter each time. So this is a, this is or. So what will this give us then? So let's see. Our sum to infinity of this particular series here is a, which is a half, divided by 1 minus a quarter. So that will give me a half on the top, and on the bottom I'll get 1 plus quarter. So that will give me, let's see, a half on the top, and 1 plus a quarter, that's 5 over 4, I think it is, isn't it? 4 ones 4, 5 over 4, yeah, 1 and a quarter. So let's see, we're dividing by a fraction here, so let's do it over here. So that'll be a half. It's going to be multiplied. We're going to flip this and multiply, if you like. So it's 4 over 5. So that will give me 4 ones 4, 2 fives 10. So that gives me 2 over 5, 2/5. So this particular series here, if we keep adding these numbers, keep on adding these numbers, eventually we're going to approach 2 over 5 here. Okay, so that's the limit of this series as n approaches infinity. Okay, so let's just have a look at another way this particular topic can be used. If we take the numbers, or the number rather, 1.33333, and this 3 here continues on forever. It's a recurring decimal. 3 continues on forever. What we want to do is write this particular decimal as a fraction. Can we write this as a fraction? So you can probably guess anyway that it's going to be 4 over 3. Okay, 3 into 4 is 1 left over, so it's going to be 1 1/3. Okay, now let's see how we can get this. So there are two ways of doing it. There's the geometric series way, and there's another way which I'll show you in a minute. But let's have a look at this particular decimal here. What way can we break this down? So we can say that that's going to be a 1 anyway, and we can add a 0.3. That'll give us out as far as here. That's 1.3. We can add a 0.03. So this will give us 1.3.3 plus 0.003 plus 0.0003, and so on. That will go on forever. Okay, so you can see that this part of our decimal here is made up of all of these 3's here. Now we can separate this out. We can take this part here, and we leave the 1 out here. So what's this equal to? Well, we can see that this is 1 plus, and inside our brackets here we actually have a geometric series. We have a geometric series here where our a is going to be 0.3. A is 0.3. The first term is 0.3, and our or here, what do we multiply each of these by to get the next term? Well, it's just going to be 1/10. If we multiply this by 1/10, we get 0.03. Multiply this by 1/10 or divide by 10, we get 0.003. Divide this by 10, we get 0.0003, and so on. So really this here is the sum of an infinite geometric series where a is 0.3 and or is 1/10. So it's the sum of an infinite series where our a is 0.3 and 1 minus our or here is 1/10. So really this is what we have to calculate, this bit here. And this bit here is just another way of writing all of this here, the sum of an infinite series. So let's do that then and see what we end up with. Well, we've got our 1 here plus what we end up with inside our brackets here. Well, we have this bit here. This is the bit we want to do. So let's see, that's 0.3 divided by 1 minus 1/10. So that's going to be 9/10. 0.3 over 9/10. So that's going to give us, let's see, I'll just draw that in there again. We'll move this up a little bit again. And this will give us 1 plus. Now flip this upside down and multiply again. We got a fraction on the bottom, so that's 0. So I'll just change that to white. So this will give us 0.3 times 10 divided by 9. So that will give me 1 plus 0.3 times 10 is just 3 over 9. So that is 1 plus 3/9, or that's just 1 and 1/3. This is 1/3 here. So we end up with 1 and 1/3, or 3 1s 3. 1 is 4 over 3. Which is what I guessed at the beginning, 4 over 3. So 1.3333 and so on can just be written as 4 over 3 as a fraction. Now another way of doing that without using geometric series is just simply write it down. Let's see, what did we start with? 1.33333, and we'll call it x. Okay, we'll call that x. Multiply it by 10, you'll get 10x. Multiply this by 10, you get 13.3333 and so on. Subtract the 2, so I'm going to take 10x minus x. So I'm going to take this minus this. So that's all of this minus this, and you can see that you'll end up with 13 minus 1, which is 12, and all of these 0.3s minus all of these 0.3s will just give me 0. So I just end up with 12. So 13.333 minus 1.333 will just give me 12. Now 10x minus x is just x. 10x minus x is just x. And, sorry, 10x minus x is 9x. Sorry, my fault. 10x minus x is 9x is equal to 12. And divide across by 9, you get x is equal to 12 over 9. Divide top and the bottom by 3. You'll get 4 over 3. So that's another way of doing it. So just let x equal to your number, multiply by 10, subtract. So you get 10x minus x is 9x, divide across by 9, and you get 4 over 3, which is what we got here.